Muted.
All right, everyone. Well, thanks for joining us today for this webinar. We are going to be covering design efficiency with tools found in SOLIDWORKS Pro and Premium. My name is Travis Jones. I will be the presenter today. And along with me on the line, I have Marcus Brown, the most certified SOLIDWORKS user in the world. And he will be fielding your questions today throughout the webinar. If you have any questions, use the chat feature on your GoToWebinar dashboard. Just go ahead and type those into the dialog box, and Marcus will answer those for you throughout the webinar. Just a little bit about me personally. I'm an application expert here at MLC CAD Systems with a background in mechanical engineering. I work out of our Austin, Texas office, and I've been with the company for about 2 years now. So it's possible that we may have spoken on the phone on a support call, or maybe I taught you in a training class. If not, hopefully I'll get to speak with you in the near future. Again, this webinar is going to cover basically 5 tools in SOLIDWORKS Pro and Premium that I think will help make your design process more efficient. So while we're on the topic of efficiency, I've got a quote here and an analogy that I think relates pretty well to this situation. Here's a quote from Abraham Lincoln, and it says, "If I had 6 hours to chop down a tree, I'd spend the first 4 hours sharpening the axe." And so the axe is a really, really great tool. It's a very efficient tool, and I think it's a lot like some of the tools you may be using right now in SOLIDWORKS Standard. Nobody doubts the effectiveness of an axe for cutting down a tree, but just like Abraham Lincoln said, there might be some prep work that goes into it. So if we think about the tools you're using now, they're very effective, but they might require prep work like sketching, reference geometry, profiles. And I want to introduce to you today tools that are more like a chainsaw. The chainsaw totally revolutionized the logging industry and made that process much more efficient. So I hope to show you 5 tools today that are going to make your design process more efficient as well. And today we've got a little bit of a challenge, and this is kind of the basic overview. I've got a buddy who owns a brewery, and he's looking to add in 2 new fermentation tanks that he can use to brew very specific craft beer. Now, he did most of the heavy lifting for us, and he actually designed the tanks, but he's going on vacation, and he asked me to help complete the design for him. We need to create this design and make sure that it's up to spec. We also need to keep his business partner in the loop. His business partner handles most of the financing side of things, but he does like to know what's going on, so we're going to make sure that we get some prints over to him, and that way he knows what our design entails. Also, we need to sell the idea to investors. The investors have actually already given us the necessary funds, but we want to make sure that these guys are on board, they're excited, and they know that their money was well spent. And of course, throughout this whole project, we're going to use tools found in SOLIDWORKS Premium and a few found in SOLIDWORKS Pro to maximize our efficiency. So to start off, these are the 2 fermentation tanks, and we need to connect these tanks with a pipe subassembly. So if we take a look at these tanks inside of SOLIDWORKS, you can see that each tank has 3 flanges on it, and we're going to create a subassembly that connects the flange from the side of tank 1 with the upper flange on the front of tank 2. And if you were using SOLIDWORKS Standard, the way you might do this would be to model a flange, insert 2 flanges, 1 on each tank, and then perform a sweep between those 2 with the profile of your pipe. We're going to use SOLIDWORKS routing. Routing is a feature found in SOLIDWORKS Premium. And to start off, we're going to go to our design library where we have a routing folder full of standardized routing components. We'll jump into piping, flanges. Here I've got 3 standardized flanges. All I'm going to do here is just simply drag one of these off the screen and mate it with an existing flange. I'll be asked to confirm the configuration, and it's as simple as that. I don't have to model these flanges. They're already pre-made for me. We'll drop in another flange on our second tank, confirm our configuration, and now we need to route a pipe between these 2 flanges. Now again, in SOLIDWORKS Standard, you might go through and use a sweep feature to make this, but that would require sketching, reference geometry, and profiles. Routing actually contains a feature called auto route. So if we go up to our piping tab on the command manager and hit auto route, we'll select both of our flanges, and SOLIDWORKS will automate this route for us. And you can see this route is driven by a sketch. So if I needed to change any of the dimensions or the way this route is laid out, I can do that. Let's say, for instance, that my company specifies that we have 8 inches of lead off of these flanges to make sure that we have room to access the flanges when we install them using bolts. We need to make sure that our tools get in there. We can come in and just modify these dimensions and our route updates. So with that, we've got this nice fully defined sketch. We can exit that, and in no time flat, we've actually created this subassembly pretty easily. So our task was to connect the tanks with a pipe subassembly, and to do that, we use routing. Routing is found in SOLIDWORKS Premium, and it lets us drag and drop standardized components from our library right into our assembly. It also lets us auto-route pipes, tubes, and electrical components, so we avoid all of the tasks associated with creating reference geometry for our sweep feature. But more importantly, it lets us save time and standardize our designs. Again, auto-route's going to save us the time by avoiding all the tasks associated with the sweep, and we standardize our designs because we have a library full of standardized routing components. So with that completed, we need to keep my buddy's business partner informed. We need to send a copy of the design to him, but he is not a SOLIDWORKS user. He does, however, handle a lot of the finances, and he's actually going to handle the ordering of all the material for this subassembly. So he might have the need to pull off measurements. So let's see how we can accomplish this using SOLIDWORKS Pro and Premium. If you had SOLIDWORKS Standard, you might be tempted to just send him over a screenshot of the subassembly. We can open that up here, but that really wouldn't give him all the info he needs. Your next option would probably be better, and that would be to create a drawing. A drawing would be pretty easy to create. It might take us a few minutes in SOLIDWORKS, but I'm worried without an engineering background, he might find that a little overwhelming. So we're going to use eDrawings, and you guys are familiar with eDrawings, but in SOLIDWORKS Pro and Premium, we actually have eDrawings Pro. So if I publish this up to eDrawings Pro, we still have the ability to manipulate and maneuver our model in 3D space. We can take section cuts if we want, we can do markups, but more importantly, we have the ability to measure, and that is a feature unique to eDrawings Pro. So if this business partner needs to measure the diameter of a flange, he can pull that measurement right off the model in eDrawings. If he needs the distance between 2 flanges, we can get him delta XYZ. Or for instance, he needs the diameter and length of a section of pipe when he goes to order it, he can pull that as well. So with eDrawings Pro, we can send files to non-SOLIDWORKS users and give them the ability to be completely self-sufficient with these files. So our task was to keep the partner informed. We needed to send a copy of the design to him, and the catch was he is not a SOLIDWORKS user. So we used eDrawings Pro, which is found in SOLIDWORKS Pro and Premium. Lets us measure and manipulate SOLIDWORKS models in a very lightweight and easy-to-use application. He's not going to need a dedicated workstation. He can even run this on a tablet, and we don't have to worry about him coming and bothering us when he needs measurements. He's completely self-sufficient. More importantly, eDrawings Pro lets you quickly communicate your designs with people outside of your engineering department, people with no engineering background, or even people outside of your company. And anytime you can quickly and effectively communicate your design, you're going to make your design process more efficient. So now that we've kept the partner in the loop here, let's see what we've got next. Is it safe? You guys know anybody like this gentleman on the left? Pull-up bar, don't you mean a door frame? My buddy let me know that they have a group of guys on the floor that they're real good guys, but they're also CrossFit junkies. And most of the time they can, behave themselves, but on days when they get to test new batches of beer, they've been known to get a little rowdy. And he's worried they might see that nice, shiny new pipe assembly we've designed and use it as a pull-up bar. So we're going to run stress-strain analysis in SOLIDWORKS and determine if our design needs to be modified for strength. So we'll jump back into SOLIDWORKS here, and included in SOLIDWORKS Premium is the ability to perform simulation. So we'll go ahead and start a new simulation study here, and SOLIDWORKS Premium gives us the ability to perform finite element analysis on parts and assemblies. So when we start a new study, you'll see I have this nice new simulation tree, and we're just going to work our way down. So the first step for simulation is to apply a material. We'll just apply a plain carbon steel. And applying material to an assembly gives our assembly all the inherent properties of that material, which is going to be necessary when we perform our stress-strain analysis. The next item we need to tackle is fixtures. So really this isn't our entire assembly, it's only a sub-assembly. And we're not really concerned about deformation of our tanks. we're going to assume that our tanks are rigid enough, they're not going to deform at all. So we need to define how this subassembly would be fit in this environment. In this case, we're simply going to remove all degrees of freedom from each of our flanges where they would connect with our fermentation tanks. Now that we've applied our material and we have fixed our geometry, we're going to apply a simulated load. So we're going to apply a force to this subassembly. And if you imagine somebody doing a pull-up, they would probably look at this center section here, and a pull-up would apply a downward force. So we'll select this section of pipe, and we'll apply a force in a selected direction. In this case, we are going to apply a force in the downward direction. And I assume that probably 350 foot-pounds is about the maximum force we would see here. And we'll go ahead and confirm that selection. So with our material applied, our fixtures defined, and our load, the next thing we need to do is the most essential step to any simulation, and that is to apply a mesh. And at its most basic form, you can think of a mesh as a way to subdivide your subassembly or your component into smaller elements. Each of these elements will then be calculated for stress and strain with our applied load, and together they will make up a solution for our simulation. So we'll go ahead and with our mesh completed, we will run this simulation. It's a pretty simple simulation. It'll take us about 10 seconds to solve. And once it's done, we will see what is basically an exaggerated deformation. SOLIDWORKS is giving us a visual cue saying, if you had applied a very, very heavy load to this assembly in the direction you specified, do you expect it to deform in this direction? In this case, we do. We would expect that pipe to bend downwards. Right now, we're also looking at a result plot. We're looking at our stresses, but I really want to look at two plots in specific. I want to look first at displacement. And using this chart, we can see that right here in this corner, we're experiencing a maximum deflection of just under 1/10 of an inch. That's probably pretty acceptable in this case. That's pretty good for this type of assembly. The next plot I would like to look at is our factor of safety. So if we look at our factor of safety plot, I can see that our minimum factor of safety is just under 2. And I think that's perfectly acceptable for this application. I don't think we're going to see any breakage or plastic deformation if somebody decides to do a pull-up on this bar. I think we're good, and I don't think it needs any modification. So we were tasked to make sure that the CrossFit junkies aren't going to tear up our new subassembly, and for that we used SOLIDWORKS simulation, which is found in SOLIDWORKS Premium, and it lets us calculate the integrity of our design. It also lets us perform FEA inside of SOLIDWORKS during the initial stages of design. We don't have to worry about kicking out our design to another department so someone can run a specialized FEA software on our part. We don't have to worry about outsourcing to another company. We can perform FEA inside of SOLIDWORKS concurrently with our design process. So overall, SOLIDWORKS simulation lets us optimize our design when changes are least expensive. We're able to minimize the number of prototypes we have to make for our part. We can minimize the number of design changes we have to make. And ultimately, we're going to get our product to market quicker, saving time and money. So now that we know our assembly is strong enough, let's see what we have next on our list. What about fasteners, right? So we created this assembly, and it looks pretty good in our model, but really the only thing keeping it in place are our assembly mates. So we need to create some fasteners and bolt down our assembly. We'll jump back to our main SOLIDWORKS model. And if you had SOLIDWORKS Standard, there are probably 2 to 3 ways that you would accomplish this task. First, you might actually go in and model your own fasteners. That would be a hugely inefficient use of your time. Modeling fasteners that your company is just going to outsource or order from a catalog is not a good way to spend your time at work. The next option would be to not use fasteners at all. That's not a terrible option. You guys know that you're just going to order them anyways. Maybe you just throw in a table into your drawings or have a call out. But if you do need fasteners, the last option would be to go online and maybe download them. You guys have probably all jumped on McMaster-Carr's website, downloaded fasteners. It's just not that efficient. You know, if your design changes and you need a new fastener, you have to navigate back away from SOLIDWORKS, back online, and you have to worry about how you're going to organize, you know, these thousands of fasteners that your company uses. So with SOLIDWORKS Pro and Premium, we have a feature called the Toolbox. If I go to my design library, navigate to the Toolbox, what I have here are basically a number of fastener standards. So if I drill down into ANSI inch, you can see that I've got bearings, bolts, screws, nuts, retaining rings. It's essentially a Fastenal catalog built into SOLIDWORKS. So if I drill down into bolts and screws and grab a hex head bolt, I can drag this hex head bolt right onto my flange, and if I hover over a cylindrical face, it's going to drop that fastener and auto-size it. So you can see that it automatically jumped to 5/8 by 18, and then I can specify my length. The nice thing about this length tool is that it actually stops at industry standards, so I don't have to worry about accidentally creating some oddball bolt that nobody in the industry uses, that Fastenal doesn't even make. It's going to stop right at a fastener that I can order out of a catalog. Once I've specified the size and length of my fastener, I can continue to just place that same fastener over and over. So we'll go ahead and drop in 8 of these bolts, 4 on each flange. And once we've got these, we'll go back and do the same with a set of hex nuts to complete our fasteners. So we'll jump back into our toolbox. We'll go to nuts, hex nuts, and I'll just grab a standard hex nut here and drag it onto my bolt face. Let me grab that again. Perfect. And again, it'll auto-size to 5/8 by 18, same size as my bolt. And then we can just drop these over and over. Go to our other flange, do the same. And should be one last bolt on the other side. Perfect. So in just a matter of minutes, we were able to find 2 different fasteners and drop 8 of each fastener into our assembly, finishing our assembly design. So our task was to bolt down our assembly and create fasteners, but with SOLIDWORKS Toolbox, we do not have to create fasteners. We have a huge library of standardized fasteners built into SOLIDWORKS. You can use these fasteners very simply. You drag them on the screen, you drop them on a cylindrical face, they auto-size, they're all industry standards, and most importantly, you're not wasting time modeling parts your company is just going to purchase. That is a huge, inefficient waste of time, and your time is much better spent optimizing your design to get a better end result. So with our assembly complete, let's see what our next task is. So our final task is to sell the investors on our idea. We need to create an attractive image that gets people excited. The investors already sent over their money, but as with any investment, sometimes you might have second thoughts. So we need to make sure that these guys are excited about our new tanks, they're excited about the idea of brewing some new beer, and they know that their money was well spent. So let's see how we can create an attractive image inside of SOLIDWORKS. If you had SOLIDWORKS Standard, your options would probably be to maybe turn on Real View graphics and take a nice screenshot. Real View graphics look pretty good, but you can kind of tell that they are not, in fact, a very, very realistic image. They do serve their purpose, though. The next option might be maybe take an image, send that to somebody with Photoshop or some sort of rendering agent, have to wait on them to finish your project and send it back. If the design changes, you have to repeat that process over and over. With SOLIDWORKS Pro and Premium, we have something called Photoview 360, which is a photorealistic rendering agent. So let's use that to create a really nice image that we can send over to the investors and get them excited. So the first step I'm going to do is to insert a background. And if I go into my scenes, I've actually already saved a background that I created. And it's just an image from the brewery that these are going to be inserted into. So you can see now we've just got a simple image as our background. The next thing I'm going to do is position these tanks in a way that that they would look, once they're installed. So I'm actually going to turn on a view called Perspective View, and that'll make this a little more realistic. And then we're just going to try and position these tanks right where their final installation is going to be. Something like that. And once we've got them positioned how we like, we'll go up to our rendering tab, which is in SOLIDWORKS because we have Photoview 360 activated. You have a number of options for all your rendering, but we're just going to do a very, very basic rendering. I'll hit Final Render, and my CPU is going to go through and calculate all the reflections, all the surface finish, all the shadows, and you can actually see that process happen through this preview window. You can see all the processors on my CPU chipping away at this image. And what we're left with is a very, very realistic image. And I'll actually show you the finished process here, or the finished product rather, in PowerPoint. And that's what our image looks like once it's gone through Photoview 360. At first glance, you might not even know that those two tanks are not in fact real, that they're just models that we have rendered inside of SOLIDWORKS. And that is because Photoview 360 lets us generate very, very realistic images. You can create attractive renderings based right off of your models, and it's inside the same familiar SOLIDWORKS interface. You don't have to jump out of another program. You don't have to send your models over to another department. You're completely self-sufficient to market your products right inside of SOLIDWORKS. And ultimately, you're marketing your design earlier on and generating interest. So early on in the design process, as soon as you have a model, you can render your model, generate interest, send that out to your marketing team, and that's going to create interest in your product before it ever hits the market. So with all 5 of these tools complete in SOLIDWORKS, let's go ahead and jump back and take a look at what we've done. First, we use SOLIDWORKS routing to save time with a standardized library of routing parts and the auto route feature. So we didn't have to model our flanges. We just simply grabbed them from our standardized library, and we had auto route, which let us save time by automating the task of performing a sweep on our pipe. The next thing we did was we used eDrawings Pro to communicate our idea with a non-SOLIDWORKS user. So eDrawings Pro lets you send out models to non-SOLIDWORKS users, people outside of your engineering department, people outside of your company. They can grab measurements, they can manipulate the model, and anytime you can communicate your ideas more effectively, you're going to make your design process more efficient. The third thing we did was we used SOLIDWORKS simulation. We needed to make sure that the CrossFit junkies weren't going to tear up our new assembly when they treated it like a jungle gym. And SOLIDWORKS simulation lets us save time and money by optimizing our design early on. We can perform FEA directly inside of SOLIDWORKS while we model, and ultimately we can reduce the number of prototypes and the time to market for our designs, which is going to save us time and money. Fourth, we use SOLIDWORKS Toolbox and its standardized library of fasteners. The Toolbox is time-saving and it's organized. Please do not spend time modeling fasteners in SOLIDWORKS. Use the Toolbox. It's easy to use, drag and drop, auto size, and it's far more organized than any of us could ever hope to be. And lastly, we used Photoview 360 to create photorealistic images to market our design. So Photoview lets us market our design with our SOLIDWORKS models. We can create very, very realistic images and generate interest from the very get-go of our design. So anytime we've got design or interest leading up to the release of a product, that's going to make our design more successful in the end. So with that in mind, what is next for you guys? Well, first, if you have SOLIDWORKS Pro or Premium, start using these tools, right? Can you imagine how excited the guys were who first got to use a chainsaw after chopping down trees with an axe their whole life? That is how your design process is going to be when you start using these tools. It's going to be much more efficient than it is now. Second, if you do not have SOLIDWORKS Pro or Premium, contact your local MLC account rep to discuss what it's going to take to upgrade your seat of SOLIDWORKS. I am not on the sales side of things, so I do not know the pricing off the top of my head. I do, however, know that it's the end of the quarter, and in the past we've always run specials on SOLIDWORKS products. I know I spoke with a few people before the start of the webinar today. We can do a 7-day trial on SOLIDWORKS Premium if you guys want to experience these tools for yourself. I know that we have buy one, get one half off on seats of SOLIDWORKS. We have 30% off SIM upgrades, and if all else, get in touch with your MLC account rep. I've spoken with a few of them personally leading up to this webinar. They're willing to work with you guys to put together a custom package and a discount on upgrading your seat of SOLIDWORKS Standard or Pro to Premium. Lastly, if all else fails, contact me. If you don't know who your MLC account rep is, here's my email address, my phone number. Get in touch with me. I can direct you to the right person. I'm also more than happy to go over some of these tools with you personally if you're concerned about the specific application of these tools with your design. So with that being said, does anyone have any questions? All right, I don't see any questions. So if you guys do have any questions after the fact, if you get to thinking, shoot us over an email. You can shoot an email to my email address here. I'm happy to talk with you guys after the fact. If not, you guys have a great Easter weekend, and we will talk to you guys soon.